You drop a cup, it shatters on the floor, and then you wait. You wait for the pieces to jump back together, fly up into your hand, and become a cup again. You're going to be waiting a long time. This is so obvious that it sounds stupid to even say it. Of course broken cups don't reassemble themselves. Of course spilled milk doesn't flow back into the glass. But here's the thing that should bother you. Why not? No, seriously, why not? Because if you look at the laws of physics, all of them, the laws of gravity, electricity, magnetism, nuclear forces, every single one of them works perfectly well in reverse. Run the movie backwards and the physics still makes sense. A planet orbiting the sun? Film it, reverse it, and it's still a valid orbit. The physics doesn't care which direction time goes. Every collision of atoms, every interaction of particles, it all works forwards and backwards equally well. So if all the fundamental laws are reversible, why is the world so obviously not? We remember the past, we don't remember the future. Think about that. We have memories of yesterday, last year, our childhood. But the future? Nothing. Blank. We can guess, we can predict, we can hope, but we don't remember it. We feel like we can affect the future. We make choices, we take actions, we try to change what's going to happen. But the past? It's done. Fixed. You can regret it, you can feel remorse about it, but you can't change it. This difference between past and future is so built into our experience that we barely notice it. But it's strange. It's really strange, because the atoms don't know the difference. And now, you might think there must be some law somewhere in physics that says time only goes forward, some rule that says particles can only move this way, not that way, some fundamental principle that makes the past different from the future. But we haven't found it. After centuries of looking, we haven't found any law that distinguishes past from future. The equations work both ways. So where does the arrow of time come from? Let me show you something. Take a box. Divide it in half with a partition. Put white gas molecules on one side, black gas molecules on the other. Now remove the partition. What happens? The gases mix, obviously. The white molecules drift into the black side, the black molecules drift into the white side, and pretty soon you have a uniform gray mixture everywhere. Now, if you wait long enough, will the gases ever unmix? Will all the white molecules ever spontaneously go back to one side, and all the black molecules go back to the other? Technically, yes. It's possible. The laws of physics allow it. If every single molecule happened to be moving in exactly the right direction, at exactly the right speed, they could all end up separated again. But the chances of this happening are so small, so incredibly tiny, that you would have to wait longer than the age of the universe. Much, much longer. The number of years you'd have to wait has more digits than there are atoms in the observable universe. So it's not going to happen. Or push a heavy block across the floor. It slides, slows down, and stops. The friction between the block and the floor brings it to rest. Now wait. Wait for the block to suddenly start moving again. Wait for the floor to push it back toward your hand. You're going to be waiting forever. The energy of the moving block didn't disappear. Energy never disappears. It transformed. It became heat. The friction warmed up the floor, just a tiny bit. The organized motion of the block, all those atoms moving together in the same direction, became disorganized motion. Atoms in the floor jiggling randomly in all directions. That's entropy. Right there, in a sliding block. The organized motion became disorganized motion. The energy spread out. The information about which direction things were moving got lost in the chaos of random thermal jiggling. Every time you see friction, every time something slows down and stops, you're watching entropy increase. You're watching organized motion become disorganized heat. You're watching the arrow of time in action. Your car brakes. Entropy increases. A ball bouncing lower and lower until it stops. Entropy increases. A pendulum slowly coming to rest. Entropy increases. It's everywhere. It's constant. It's relentless. But why? Why doesn't the block ever slide back? Why don't the gases unmix? Each individual molecule is just bouncing around randomly. There's nothing stopping any particular molecule from going left or right. So why don't they ever all go to one side? It's about counting. It's about the number of ways things can be arranged. Think of it this way. You shuffle a deck of cards. What are the chances that after shuffling, all the hearts are together, All the diamonds are together, all the clubs are together, and all the spades are together. Almost zero. Not because any particular arrangement is forbidden. Any specific arrangement of 52 cards is equally unlikely. But there's only one way to have them perfectly sorted, and there are billions and billions of ways to have them mixed up. So, when you shuffle, you almost certainly go from order to disorder. Not because of any fundamental law, but because there are so many more ways to be disordered than to be ordered. And that's entropy. Entropy is, you can think of it as a measure of disorder. But more precisely, it's a measure of how many different microscopic arrangements could produce the same macroscopic appearance. When the gas is separated, white on one side, black on the other, there's only a limited number of ways the molecules can be arranged while still looking separated. But when it's all mixed together, there are astronomically more arrangements that all look the same, gray everywhere. So the gas mixes not because mixing is a law of physics, but because there are vastly more mixed states than unmixed states. It's just probability. Overwhelming, crushing, inevitable probability. Now watch this. The laws of physics don't have a direction, but probability does. Probability says you almost always go from less likely states to more likely states, from fewer arrangements to more arrangements, from order to disorder. And that's where the arrow of time comes from. The past is when there was more order. The future is when there will be less order. We remember the past because our brains record information, and recording information requires order. We can't remember the future because it hasn't been ordered yet. Let me put it another way. Every time you break an egg, you're increasing the entropy of the universe. The egg had order, shell intact, yolk in place, everything arranged just so. The broken egg has less order, pieces scattered, yolk spreading, chaos. Could the egg unbreak? Could all those pieces fly back together and reform a perfect egg? In principle, yes. Every atom could reverse its motion. But the chances are so impossibly small that it will never happen in the lifetime of the universe. So the egg stays broken, and time moves forward. This is profound. Really think about this. The difference between past and future, this thing that feels so fundamental to our existence, it doesn't come from the laws of physics at all. It comes from statistics. It comes from counting. It comes from the simple fact that there are more ways to be messy than to be neat. Every moment of your life, you're riding the wave of increasing entropy. Every breath you take, every thought you think, every action you perform, it all increases the disorder of the universe just a little bit. And that's why time has a direction. But wait, there's a problem. If entropy always increases, if everything always moves toward disorder, then why is there any order at all? Why isn't the universe just a uniform gray soup of randomly scattered particles? Look around you. There are stars, galaxies, planets. There's life. There's you, sitting there with your incredibly organized brain, full of neurons firing in precise patterns. How did all this order come to exist in a universe that's supposed to be falling apart? The answer takes us back to the very beginning, the Big Bang. For some reason, and honestly we don't fully understand why, the universe started in a state of incredibly low entropy, extremely high order. Everything was packed together, organized in a very specific way. And ever since then, entropy has been increasing. The universe has been unwinding, moving from that initial order toward eventual disorder. So when you see a star burning in the sky, you're not seeing order being created from nothing. You're seeing the slow release of the order that was built into the universe from the beginning. The star is spending the cosmic inheritance, you might say. Think about it this way. Imagine you have a giant spring, wound up incredibly tight. That's the early universe, full of potential, full of stored order. And everything that has happened since, every galaxy forming, every star igniting, every planet cooling, every life form evolving, it's all just the spring unwinding. We're living off the low entropy of the past. Now you might ask, if the laws of physics are reversible, couldn't we argue that the future also has low entropy? Couldn't we say that the universe will eventually wind back up again? No, and here's why. Suppose you're looking at a box of gas that's half mixed, some white molecules, some black molecules, kind of swirled together but not completely uniform. Now I ask you, what was this gas doing a few minutes ago? And what will it be doing a few minutes from now? If you assume the mixing happened by accident, by random fluctuation, then the most likely answer is that it was more mixed before and it will be more mixed after. The current partial separation is just a temporary fluctuation, and the gas is on its way back to being fully mixed. But that's not what we observe. We observe that the past had more order and the future has less. The gas was separated before, and it will be fully mixed after. This tells us something crucial. The order we see in the world is not due to random fluctuations. It's not an accident. It's a memory of an initial state of very high order. Suppose you look at one corner of a room and you see some order. Maybe the gas molecules there happen to be arranged in an unusual pattern. If this order came from a random fluctuation, then you would expect the rest of the room to be completely disordered. The fluctuation would be local. But when astronomers point their telescopes at new parts of the sky, parts they've never looked at before, they find order there too. Stars burning, galaxies spinning, the same patterns everywhere. This tells us the order is not a fluctuation. The order is universal. It came from the beginning. So the entire arrow of time, the entire distinction between past and future, traces back to one fact. The universe started with low entropy. Everything else follows from that. Why do we remember the past but not the future? Because memories are records, and records require order. The low entropy of the past allows records to be formed. The high entropy of the future doesn't. The whole structure of our experience, cause and effect, memory and anticipation, birth and death, it all traces back to entropy. The Big Bang wasn't just an explosion. It was an explosion of order, a release of potential. And everything that has happened since, every star, every planet, every life form, every thought you've ever had, is riding that wave of increasing entropy. We don't know why the universe started that way. We don't know what set up those initial conditions. It remains one of the great mysteries. But we do know this: the arrow of time points from low entropy to high entropy, from order to disorder, from the past to the future, and there's no escaping it. Now, people sometimes get confused. They look around and they see order. They see crystals forming. They see plants growing. They see babies being born and developing into complex adults. And they ask, doesn't life violate entropy? Aren't living things becoming more ordered over time, not less? No, life doesn't violate entropy, not even close. Yes, a growing plant becomes more ordered. Yes, a developing embryo becomes more complex. Yes, your brain is an incredibly organized structure. But none of this happens for free. To grow, a plant absorbs sunlight. That sunlight is low entropy energy, organized, concentrated, coming from one direction. The plant uses that energy to build its structures, and in the process, it radiates heat back into the environment. That heat is high entropy energy, disorganized, spread out, going in all directions. The total entropy, plant plus environment, increases, always. You are the same way. You eat food. Food is organized, complex molecules arranged in specific patterns. Your body breaks down that food, extracts the useful energy, builds and repairs your tissues, and in the process, you radiate heat. You exhale carbon dioxide. You produce waste. The order in your body is borrowed. It comes from the order in your food, which came from the order in sunlight, which came from the order in the sun, which came from the order in the gas cloud that formed the sun, which came from the Big Bang. So you are not fighting entropy, you are surfing it. Life is not a violation of the second law of thermodynamics. Life is a particularly interesting way of increasing entropy. We are entropy increasing machines that happen to be conscious. Think about that for a moment. Every breath you take increases the entropy of the universe. Every thought you think, because thinking requires energy, and energy use produces heat, increases the entropy of the universe. Every moment you're alive, you're contributing to the great unwinding. But along the way, You drop a cup, it shatters on the floor, and then you wait. You wait for the pieces to jump back together, fly up into your hand, and become a cup again. You're going to be waiting a long time. This is so obvious that it sounds stupid to even say it. Of course broken cups don't reassemble themselves. Of course spilled milk doesn't flow back into the glass. But here's the thing that should bother you. Why not? No, seriously, why not? Because if you look at the laws of physics, all of them, the laws of gravity, electricity, magnetism, nuclear forces, every single one of them works perfectly well in reverse. Run the movie backwards and the physics still makes sense. A planet orbiting the sun? Film it, reverse it, and it's still a valid orbit. The physics doesn't care which direction time goes. Every collision of atoms, every interaction of particles, it all works forwards and backwards equally well. So if all the fundamental laws are reversible, why is the world so obviously not? We remember the past. We don't remember the future. Think about that. We have memories of yesterday, last year, our childhood. But the future? Nothing. Blank. We can guess, we can predict, we can hope, but we don't remember it. We feel like we can affect the future. We make choices, we take actions, we try to change what's going to happen. But the past? It's done. Fixed. You can regret it, you can feel remorse about it, but you can't change it. This difference between past and future is so built into our experience that we barely notice it. But it's strange. It's really strange. Because the atoms don't know the difference. And now, you might think there must be some law somewhere in physics that says time only goes forward. Some rule that says particles can only move this way, not that way. Some fundamental principle that makes the past different from the future. But we haven't found it. After centuries of looking, we haven't found any law that distinguishes past from future. The equations work both ways. So where does the arrow of time come from? Let me show you something. Take a box. Divide it in half with a partition. Put white gas molecules on one side, black gas molecules on the other. Now remove the partition. What happens? The gases mix, obviously. The white molecules drift into the black side, the black molecules drift into the white side, and pretty soon you have a uniform gray mixture everywhere. Now, if you wait long enough, will the gases ever unmix? Will all the white molecules ever spontaneously go back to one side, and all the black molecules go back to the other? Technically, yes. It's possible. The laws of physics allow it. If every single molecule happened to be moving in exactly the right direction, at exactly the right speed, they could all end up separated again. But the chances of this happening are so small, so incredibly tiny, that you would have to wait longer than the age of the universe. Much, much longer. The number of years you'd have to wait has more digits than there are atoms in the observable universe. So it's not going to happen. Or push a heavy block across the floor. It slides, slows down, and stops. The friction between the block and the floor brings it to rest. Now wait. Wait for the block to suddenly start moving again. Wait for the floor to push it back toward your hand. You're going to be waiting forever. The energy of the moving block didn't disappear. Energy never disappears. It transformed. It became heat. The friction warmed up the floor, just a tiny bit. The organized motion of the block, all those atoms moving together in the same direction, became disorganized motion. Atoms in the floor jiggling randomly in all directions. That's entropy. Right there, in a sliding block. The organized motion became disorganized motion. The energy spread out. The information about which direction things were moving got lost in the chaos of random thermal jiggling. Every time you see friction, every time something slows down and stops, you're watching entropy increase. You're watching organized motion become disorganized heat. You're watching the arrow of time in action. Your car brakes. Entropy increases. A ball bouncing lower and lower until it stops. Entropy increases. A pendulum slowly coming to rest. Entropy increases. It's everywhere. It's constant. It's relentless. But why? Why doesn't the block ever slide back? Why don't the gases unmix? Each individual molecule is just bouncing around randomly. There's nothing stopping any particular molecule from going left or right. So why don't they ever all go to one side? It's about counting. It's about the number of ways things can be arranged. Think of it this way. You shuffle a deck of cards. What are the chances that after shuffling, all the hearts are together, all the diamonds are together, all the clubs are together, and all the spades are together? Almost zero. Not because any particular arrangement is forbidden. Any specific arrangement of 52 cards is equally unlikely. But there's only one way to have them perfectly sorted, and there are billions and billions of ways to have them mixed up. So, when you shuffle, you almost certainly go from order to disorder. Not because of any fundamental law, but because there are so many more ways to be disordered than to be ordered. And that's entropy. Entropy is, well, you can think of it as a measure of disorder.
Have you ever finished reading a page, reached the end, and realized you have absolutely no idea what you just read? Your eyes moved across the words. You saw them. But somehow, nothing stayed. It's as if the information just passed through your mind like water through a sieve. This is one of the most frustrating experiences in learning. We read something important, something we need to know, and a day later it's gone. A week later, we might as well have never read it at all. So what's happening here? Why does our brain seem to let so much slip away? The answer isn't that we have bad memory. The problem is that we've misunderstood what memory actually is and how it works. Most people treat their brain like a recording device, like a camera that's supposed to capture everything it sees. But that's not how it functions. Not even close. Think about the last time you walked through your house. You saw the furniture, the walls, the doors. But right now, could you describe the exact pattern of wear on your doorknob? Or the precise number of books on your shelf? You saw these things, but you didn't encode them. Your brain didn't store them because it didn't think they mattered. This is the first thing to understand. Your brain is not trying to remember everything. It's trying to remember what's important, and it decides what's important based on very specific signals. If we want to remember what we read, we need to understand these signals and work with them, not against them. Let's start with what actually happens when you read something. The words come in through your eyes. They get processed in the visual cortex. Then they're converted into meaning in the language centers of your brain. But here's the critical part. Just because information reaches your brain doesn't mean it gets stored there. It's like the difference between someone telling you something and you actually writing it down. The information was present, but was it recorded? Memory formation requires something more than just exposure. It requires encoding, and encoding doesn't happen automatically. It happens when your brain decides that the information is worth the energy it takes to store it. Because make no mistake, remembering things costs energy. Maintaining neural connections, strengthening synapses, integrating new information with old information, all of this requires resources. So your brain is selective. Think of it this way. Imagine you're walking through fresh snow. The first time you take a path, you leave footprints, but they're shallow. If it snows again, those footprints disappear. But if you walk the same path every day, eventually you create a clear trail. The snow gets packed down, the path becomes obvious. That's what happens with memory. A single exposure creates a faint trace, but repetition, and more importantly, engagement with the material, packs that path down. But here's where it gets interesting. Not all repetition is equal. You could read the same page 10 times passively, letting your eyes glide over the words, and still remember almost nothing. Why? Because your brain isn't interpreting passive reading as a signal that this information matters. There's no struggle, no effort, no connection being made. It's like walking the same path in the snow but stepping in slightly different places each time. You never reinforce the same trail. So what does work? What makes information stick? The answer lies in something called elaborative encoding. This is the process of connecting new information to things you already know, of transforming abstract concepts into concrete examples, of asking questions about what you're reading rather than just absorbing it. Let's say you're reading about how the heart pumps blood. If you just read the heart has 4 chambers and valves that prevent backflow, that's one kind of learning. It's abstract. It's isolated. But if you stop and think, wait, why 4 chambers? Why not 2 or 6? And these valves, they're like the check valves in plumbing that keep water from flowing backward. Now you're doing something different. You're connecting the new information to something you already understand. You're asking why things are the way they are. You're building mental models. This is what makes information memorable. Not repetition alone, but meaningful processing. Your brain stores things that it has worked with, manipulated, questioned, and connected. It's the difference between hearing a phone number once and dialing a phone number. When you dial it, you have to actively recall each digit, place it in sequence, and execute an action. That active retrieval is what creates strong memory traces. There's a principle in neuroscience called the generation effect. It shows that information we generate ourselves is remembered better than information we simply read. If you read a sentence like, "The hungry man ate the pizza," you'll remember it somewhat. But if you read "The hungry man ate the," and have to supply the word yourself, you'll remember it much better. Why? because generation requires retrieval. It requires you to search your memory, to activate related concepts, to create something rather than just receive it. This is why summarizing what you read in your own words is so powerful. When you close the book and try to explain the concept to yourself, you're forcing your brain to reconstruct the information from memory. And that reconstruction process, that's what creates strong, lasting memories. Every time you successfully retrieve something, you're strengthening the path to it. Now, there's another crucial element: understanding. True understanding creates memory almost automatically. Think about the difference between memorizing a series of random numbers and understanding why those numbers form a pattern. Random numbers are hard to remember because there's no structure, no meaning. But if you understand that the numbers are the Fibonacci sequence, where each number is the sum of the two before it, suddenly they're easy. You don't need to memorize each individual number because you understand the rule that generates them. This is why reading for understanding, not just for exposure, is so important. When you understand something deeply, when you grasp not just what happens, but why it happens, you're creating a compressed representation in your mind. Instead of storing 1,000 individual facts, you're storing the underlying principle that generates those facts. It's vastly more efficient. Consider how you remember stories versus how you remember lists. Stories are easy to remember because they have structure, cause and effect, character motivation, sequences that make sense. Lists are hard because they're arbitrary. There's no inherent connection between item 1 and item 2. This tells us something important. Our memory is designed for meaning, not for arbitrary information. So when you're reading, especially something dense or technical, the key is to constantly search for the meaning. Don't just read what happens, ask why it happened. Don't just accept a statement, think about what it implies. Does this new piece of information contradict something you thought before? Does it explain something you've been confused about? Does it connect to something in a completely different domain? These questions aren't extra work on top of reading. They are the work. They're what transforms reading from a passive activity into an active one. And active processing is what creates memory. There's also the matter of timing. Our brains consolidate memories in phases. When you first read something, it exists in what we call working memory. This is temporary, like RAM in a computer. It holds information just long enough for you to use it. But for information to move into long-term storage, it needs to be consolidated. And consolidation takes time. This is why cramming doesn't work well. You can shove information into working memory right before a test, and it might be there when you need it. But a week later, it's gone. It never got properly consolidated. The information never made it from that temporary storage into the stable long-term networks of your brain. What does work is spaced repetition. Instead of reading something once for an hour, you're better off reading it for 20 minutes, then coming back to it tomorrow, then again in 3 days, then again in a week. Each time you return to the material, you're forcing your brain to retrieve it, and retrieval is what strengthens memory. The spacing gives your brain time to consolidate between sessions. But here's what makes this even more effective. Each time you come back, don't just reread. Test yourself. Try to recall the main points before you look at them again. This retrieval practice is one of the most powerful learning techniques we know of. It feels harder than just rereading. It's supposed to. That difficulty is the signal your brain needs to recognize that this information is important. Think about learning to ride a bicycle. You can watch videos of people riding bikes. You can read about balance and momentum, but you won't learn until you actually get on the bike and struggle with it. The struggle, the wobbling, the near falls, these aren't obstacles to learning. They are learning. Your brain learns by doing, by failing, by correcting. The same is true for intellectual learning. The struggle to recall, the effort to reconstruct, the work of generating answers. This is what creates lasting memory. Now, let's talk about something subtle but important. Context and cues. Memories aren't stored in isolation. They're stored in networks connected to all sorts of contextual information. Where were you when you learned something? What were you thinking about? What else was happening? All of these become cues that can trigger the memory later. This is why it's easier to remember something in the same environment where you learned it. The room, the lighting, even the smell, these all become associated with the memory. But here's the problem. If you only study in one place, your memory becomes dependent on those cues. And when you need to recall the information somewhere else, it's harder. The solution is to vary your learning environment. Read in different places. Review material in different contexts. This forces your brain to encode the information more abstractly, less tied to specific cues. It makes the memory more flexible, more robust, more accessible from different mental states. There's also the question of depth. You can read something at a surface level, understanding the basic gist, or you can read it deeply, wrestling with implications and connections. Deep processing creates stronger memories. It's the difference between recognizing a face and knowing a person. Recognition is shallow, you know you've seen them before. Knowing is deep. You understand their personality, their history, their quirks. When you read, aim for knowing, not just recognizing. This means pausing frequently. It means asking questions. What's the author really saying here? Why is this point important? How does this relate to what came before? Could this be explained differently? Do you agree with this? Why or why not? These questions might slow down your reading speed, but they dramatically increase what you retain. And here's something interesting. Over time, as you get better at this kind of active reading, it doesn't slow you down as much. You develop the skill of reading and thinking simultaneously. The questioning becomes automatic. You start to notice patterns more quickly, make connections more easily. Your understanding accelerates. Let's consider one more aspect, the role of emotion. We remember things better when they're emotionally significant. A dramatic story sticks more than a dry recitation of facts. Why? Because emotion is one of the brain signals that something matters. When you feel something, curiosity, surprise, confusion, excitement, your brain pays more attention. It encodes more deeply. This doesn't mean you need to artificially manufacture emotion while reading, but it does mean that staying engaged, staying curious, allowing yourself to be surprised or puzzled, these states facilitate memory. If you're bored, if you're just going through the motions, your brain interprets that as a signal that this information isn't important. It allocates fewer resources to encoding it. So if you find yourself bored while reading something you need to remember, that's a problem to solve, not just a mood to tolerate. Can you approach the material differently? Can you find a question within it that genuinely interests you? Can you look for connections to something you do care about? Sometimes the key to remembering isn't technique, it's finding a way to genuinely engage with the material. All of this points to a central truth about memory. It's not a passive recording. It's an active reconstruction. Every time you remember something, you're rebuilding it from pieces. And the act of rebuilding it changes it slightly, strengthens certain connections, weakens others. Your memory is alive, dynamic, constantly being reshaped by how you use it. This means that the best way to remember what you read is to use it, write about it, explain it to someone else, apply it to a problem you're trying to solve. Think about how it changes what you believed before. Let it interact with other things, Every time you actively work with the information, you're strengthening it, integrating it more deeply into your web of knowledge. The person who reads a book and then closes it, moving on to the next thing, will forget most of it. The person who reads a book and then spends time thinking about it, discussing it, applying its ideas, will remember it for years. The difference isn't in the reading itself, it's in what happens after. Here's the beautiful part. Once you understand how memory works, you stop fighting against your brain. You work with it. You recognize that forgetting is natural and expected when you don't give your brain the signals it needs. You understand that difficulty during learning isn't a sign you're doing something wrong. It's often a sign you're doing something right. That struggle to recall, that effort to connect ideas, that work of generating rather than just receiving, this is what builds lasting knowledge. Memory isn't about having a better brain. It's about using your brain the way it's designed to be used. And it's designed for meaning, for connection, for active engagement. Give it those things and you'll be amazed at what stays with you. Not because you have a special gift, but because you're working with the natural mechanisms of how learning happens. The next time you pick up something to read, something you want to remember, don't just read it. Engage with it, question it, connect it, reconstruct it in your own words. Come back to it, test yourself on it. Let it change how you think about other things. Treat reading not as a task to complete, but as a conversation to have with ideas. Do this, and you won't need tricks and mnemonics for most of what you read. Understanding itself will be your memory. The ideas will stick not because you forced them to, but because they became part of how you think. And that's not just better memory. That's actual learning.
You are completely wrong about time. You probably think you know what it is because you look at a watch or you feel yourself getting older. But that isn't time. That's just a sensation, a biological trick. Most people walk around with this poetic idea in their heads that time is a river. You imagine it flows, sweeping you along from the past, through the present, and into the future. You think it moved. But here is the problem with that beautiful image. If time is a river, how fast does the river flow? 1 second per second? That is meaningless. That's like saying a table is 1 table long. It tells you absolutely nothing about the nature of reality. The truth is much stranger, much more mechanical, and honestly, a lot less romantic than a flowing stream. Time doesn't flow. Time doesn't push you anywhere. And if you think you have a good grip on how time works, just because you can count seconds in your head, you are in for a very rude awakening. Let's start with what goes on inside your brain, because that is where the confusion begins. You think your internal clock is a reliable instrument. It isn't.
It is a chaotic mess of translation scheme. Consider a simple experiment. Try to count to 60 seconds in your head. Just sit there and count. 1, 2, 3. You think you are tracking time, but what you are really doing is running a very specific, very personal program. Some of you, when you count, you hear a voice in your head. You are literally speaking to yourself, sub-vocalizing 1, 2, 3. If someone interrupts you and asks you to speak, you lose your count. The machine jams. But others, and this is where it gets interesting, don't hear a voice at all. They see images. They might see a tape measure with numbers on it, clicking past like a ticker tape. Clink, clink, clink. If you use that visual tape measure system, you can actually read a newspaper or check a laundry list while you count time. You can sort your socks, look at patterns in the weaving, and still keep that mental tape measure clicking perfectly. But the person who counts with a voice, they can't read a word without losing track of the time. This tells us something fundamental. What you experience as the passage of time is just a mental construct, a pattern-matching game your brain plays. It varies wildly from person to person. It is not a universal constant. It is a biological hallucination. So, when we talk about physics, when we talk about the universe, we have to throw your brain out the window. We have to stop talking about how it feels and start talking about what it actually is. In physics, we have to be operational. That means we don't ask, what is the essence of time? Because that is a question for philosophers who enjoy arguing over coffee. We ask, how do we measure it? And the answer is almost disappointingly simple. Time is just a way of ordering events. That's it. It is a labeling system. Imagine you have a deck of cards. You lay them out in a row. You can say the jack is before the queen and the king is after the queen. The cards aren't moving. The table isn't flowing. The order is just a structural property of how the cards are arranged. Time is the table. Events are the cards. When we say time passes, we are just reading the cards from left to right. This brings us to the biggest mistake everyone makes. You think time is a container. You imagine the universe is a big empty box, and time is a clock on the wall of that box, ticking away even if the box is empty. You think that if we removed all the stars, all the planets, all the atoms, and all the light, time would keep ticking. Tick, tick, tick. Wrong. This is the Newtonian view, and it is dead. Time is not a background stage. Time is a measure of change. If absolutely nothing in the universe changes, no atoms vibrate, no light moves, no energy shifts, then time stops. It ceases to have meaning. You cannot define a second without a physical process to mark it. A swinging pendulum, a vibrating quartz crystal, a cesium atom oscillating. Time is not separate from the stuff in the universe. Time is a property of the stuff. This is where your intuition fights back. You say, okay, but surely time acts on things. Time makes me get older. Time causes the milk to spoil. No, it doesn't. This is a linguistic trap. Time is not an agent. Time doesn't have hands. It doesn't reach into the fridge and sour your milk. Bacteria do that. Chemical reactions do that. Entropy does that. Time is just the bookkeeping system we use to track the rate at which those reactions happen. Saying time did it is like saying inches built the house. Inches didn't build anything. Carpenters, inches just tell you where the walls are. Time is the ruler, not the worker. Let's push this ruler analogy further because this is where things get really weird. If time is just a ruler we use to measure the distance between events, what happens if the ruler itself is flexible? This isn't science fiction. This is measurable fact. We used to think that a second was a second, anywhere in the universe. If you had a clock on Earth and a clock on Mars, they would tick-tock in perfect unison. It feels obvious, it feels right, and it is completely false. The rate at which clocks tick depends on where they are and how fast they are moving. This is not a mechanical failure of the clock. It is a fundamental feature of reality. Imagine you are driving a car across a giant flat sheet of paper. You can drive north or you can drive east. If you drive purely north, you are making maximum progress in the northward direction. But if you turn the steering wheel and start driving northeast, you are sharing your speed. You are moving a bit north and a bit east. You aren't going north as fast as you were before because you diverted some of that motion to the east. Now, replace north with time and east with space. This is the essence of relativity. You are always moving through the universe at a constant speed, but that motion is shared between space and time. If you sit perfectly still in your chair, you are dedicating all your motion to moving through time. You are traveling into the future at maximum speed, 1 second per second. But the moment you stand up and walk, or get in a rocket and fly, you are diverting some of that motion into space. You are moving through space, which means you must, mathematically must, move slower through time. Your clock slows down. Your aging slows down. You aren't breaking the machine. You are just changing direction on the map. If you could move at the speed of light, which is the maximum speed limit of the universe, you would be using 100% of your motion for space. You would have zero motion left for time. For a photon of light, time does not pass. It is born and absorbed in the same instant of its own perspective. The universe is frozen. Now, you might be thinking, well, I don't feel my watch slowing down when I run for the bus. Of course not. You are too slow. You are a biological snail. The effects are tiny at human speeds, but they are real. We have to program satellites with this math. Satellites are moving fast, so their time is different from your time. We literally have to adjust their clock motion. There is another aspect of time that tricks us, and it comes back to that counting socks problem, the idea of pattern recognition. We perceive time as having a direction, an arrow. Past is fixed, future is open. You can remember breakfast, but you can't remember dinner. Why? If physics equations work forwards and backwards, and most of them do, why can't we remember the future? If you film a planet orbiting a star and play it backward, it looks perfectly fine. It obeys all the laws of gravity. But if you film an egg falling on the floor and breaking, and then play it backward, everyone knows it's fake. The yellow yolk doesn't leap off the floor, assemble itself into a ball, and seal itself inside a shell. Here's the secret. This isn't about time itself. It's about probability. It's about disorder. It is much, much easier to break an egg than to build one. There are a billion ways for an egg to be broken. Scattered here, splattered there, shell in 3 pieces, shell in 1,000 pieces. But there is only one specific arrangement where the egg is whole. So, as things move and interact, they naturally stumble from the organized state, few options, to the disorganized state, many options. We call this entropy, and this is the only reason you feel an arrow of time. You are watching the universe shuffle the deck of cards. You started with a perfectly ordered deck, and every second that ticks by is just the universe shuffling it a bit more. You can't unshuffle the deck just by hoping. This means that your sensation of time flowing is actually just your brain registering the increase of messiness in the universe. You are a disorder detector. When you distinguish the past from the future, you are really just distinguishing less messy from more messy. If the universe were in a state of maximum mess, maximum entropy, where everything was evenly spread out and nothing interesting was happening, your brain wouldn't be able to tell the past from the future. There would be no egg to break. There would be no memory to form. In a thermal equilibrium universe, the arrow of time vanishes. So, let's go back to those people counting in their heads. The ones seeing the tape measure versus the ones hearing the voice. They are both struggling to impose a rigid linear structure on a universe that is actually much more flexible. We build these mental models, these counting machines, because we need to survive. We need to know when the tiger is coming or when the harvest is ready. We evolved to track duration, but we did not evolve to understand the dimension of time. Our brains are efficient, not accurate. We focus on the now because that is where we live. But in physics, now is a very slippery concept. If you and I are standing next to each other, our now is effectively the same. But if you are on a planet 1,000,000 light years away and you start walking away from me, your definition of now slices through the universe at a different angle than mine. What you consider to be happening right now might be in my future. What I consider right now might be in your past. There is no universal now that covers the whole universe like a blanket. The universe is a block of events, a four-dimensional loaf of bread, and how you slice that loaf depends on how fast you are moving. This is hard to grasp. It feels wrong. It feels like I'm telling you that up is down. But that is because you are trying to translate the high-level language of the universe into the low-level language of your biology. You are trying to count socks when you should be measuring light beam. When you try to force the universe to fit your intuition, you get confusion, you get paradoxes. But when you let go of what you think time is, when you stop trying to count it like a pile of laundry and start measuring it like a dimension of space, suddenly the equations work. Suddenly the universe makes sense. We are not done. Because even if we accept that time is a dimension and that it stretches and squashes with speed, there is a much deeper question lurking at the bottom of the well. We talked about measuring time, and we talked about the arrow of disorder, but we haven't talked about the beginning. If time is a measure of change, what happens when you run the movie backward all the way to the first frame? If the universe is expanding and we wind it back, it gets smaller and smaller, hotter and hotter. Eventually, you hit a point where the laws of physics themselves start to melt. You see, all our clocks, our atoms, our planets, our light beams, they exist inside the universe. But if the universe itself was born in a moment we call the Big Bang, does it make sense to ask what happened before that? This is the ultimate test of your new definition of time. If time is just a way of ordering events inside the universe, then asking what happened before the universe might be as nonsensical as asking what is north of the North Pole. It sounds like a valid question grammatically, but geometrically it is gibberish. There is no north of the North Pole. There may be no time before time began. And yet we still have that nagging feeling, that internal counter, that voice counting 1, 2, 3. We desperately want the universe to have a backstory. We want a timeline that stretches back forever. It is hard to accept that the tape measure might just start, that the counting machine had an on switch. This creates a friction between our psychology and our cosmology. We are finite beings trying to comprehend the infinite, using tools made of meat and electricity. It is a wonder we understand anything at all. Consider the patterns again. The person who sees the tape measure in their head can count while reading because they are using different circuits, visual versus verbal. Physics is the same. Classical mechanics was the verbal counting. It worked for day-to-day stuff. Relativity is the visual tape measure. It allows us to process complex patterns that the old way couldn't handle. We are constantly upgrading our mental software to match the hardware of reality, and the upgrade process is painful. It requires discarding ideas we love, like the river of time. But here is the beautiful part. Even though your intuition is wrong, even though your internal clock is a biological hack, and even though time is a flexible, relative, bendy dimension rather than a strict metronome, it still works for you. You can still boil an egg, usually. You can still meet a friend for coffee at 2 p.m. The weirdness of relativity is hidden under the hood. You don't need to understand the combustion engine to drive the car, and you don't need to understand space-time metrics to live your life. But isn't it better to know? Isn't it better to know that the engine is there? This brings us back to that strange experiment with the counting. Remember the difference between the person who hears numbers and the person who sees them? This is not just a party trick. It reveals a terrifying gap in how we understand the universe. When two people talk to each other about something complex, like time or relativity or love, they think they are speaking the same language. They nod, they agree, they say, "I understand." But what is really happening? You are running a massive, invisible translation scheme. You take the words I say and convert them into your private internal imagery, which might be completely different from mine. I say 1 minute, and I see a clock face. You hear a voice saying 60 seconds. We arrive at the same answer, so we think we agree, but the machinery inside is totally alien. This matters for physics because it exposes the fragility of common sense. Common sense is just the collection of prejudices you acquired by age 18. It is built on your specific internal imagery. If your mental image of time is a tape with numbers on it, you will struggle to understand how time can bend. If your mental image is a voice counting, you will struggle to understand how time can be spatial. When we try to teach you about the quantum vacuum or the curvature of space-time, we aren't just giving you new facts. We are asking you to delete your operating system. We are asking you to throw away the tape measure and silence the voice. And that is why it feels so hard. That is why your brain rejects it. You aren't just learning, you are translating against the grain of your own biology. So let's try to break that biology one more time. We talked about how time slows down when you move, but there is a consequence of that which is even more disturbing. It destroys the concept of simultaneity. Imagine you have two very long poles, miles apart. You decide to flash a light on top of both poles at the exact same instant. Now, you see them flash together. Simple. But now, imagine a spaceship flying past you at half the speed of light. To the person in the spaceship, those flashes do not happen at the same time. They will measure, absolutely correctly, using perfect instruments, that one pole flashed before the other. Who is right? You or the spaceship?
You are both right. This is the part that breaks the human brain. We are obsessed with the idea of a universal now. We think that right now something is happening on Mars. But right now is not a physical reality. It is a coordinate choice. If you change your speed, you slice the loaf of space-time at a different angle. You literally change what events are considered simultaneous. This means there is no universal master clock ticking in the background of the cosmos. There is no God's eye view where everything happens in a neat sequence. The order of events can actually flip depending on how you move. Cause and effect usually stay safe, but the timing is up for grabs. If now is relative and time is just a dimension like space, this leads to a conclusion that makes the river of time look like a nursery rhyme. We call it the block. If time is a dimension, then the past, the present, and the future all exist simultaneously. Think of a movie reel. You watch the movie frame by frame, so it feels like a story unfolding. But if you hold the reel in your hand, the end of the movie exists at the same time as the beginning. The frames are all there, frozen in plastic. The only thing moving is the light of the projector. In this analogy, your consciousness is the light. The events of your life, your birth, your breakfast this morning, your death, they are all just frames on the reel. They already exist. They always have. This is why physicists sometimes say the flow of time is an illusion. We don't mean it's fake. We mean it's a perspective trick. The dinosaur that died 66 million years ago is not gone in the sense of being erased from reality. It is just at a different coordinate, down the road in the time dimension. Just because New York is far away from you now doesn't mean New York ceases to exist. It's just elsewhere. The past is just elsewhere in time. The future is elsewhere in the other direction. The structure is static. The experience is dynamic. Now, you might ask, if the future already exists, do I have free will? That is the wrong question. That is a philosopher's question. The physicist's question is, does the system allow for predictability? And the answer is messy. Remember the egg breaking? That's entropy. The future is the direction of more mess. Even if the block is static, the patterns inside the block follow rules. You can't just jump to the end of the movie because the frames between here and there are the necessary steps to build that future. You are the process. You are not a passenger riding through time. You are the chemical reaction that is time. You are the shuffling of the deck. Let's go back to the counting experiment one last time because there is a hidden lesson there about capability. The person who could visualize the tape measure could do something the voice counter couldn't. He could read and count at the same time. He had a parallel processing power because his internal imagery was different. Physics gives you that power. When you stop translating the universe into rivers and flows and start seeing it as geometry, as math, as structure, you gain a superpower. You can see how black holes stop time. You can see how gravity is just the bending of the map. You stop being a victim of the illusion and start becoming a reader of the map. And yet, we must be humble. We talked about how we store information. Bessel functions, exponentials, electric fields. We learn these fancy terms. We write down these symbols, and we think we have captured reality. But remember,
The guy next to you might be storing that same Bessel function using a completely different mental image. He might see a vibrating drumhead while you see a squiggly line. We are all just blind people touching an elephant, describing it to each other in languages we barely understand. The math work, that is always a translation. We found that simple counting to a minute is susceptible to all kinds of external factors and internal methods. If our sense of a mere 60 seconds is that unstable, imagine how unstable our sense of eternity or beginning. We ask, how did the universe begin? And we expect a story like, once upon a time. But the universe doesn't work in stories. It works in states. It works in fields. It works in ways that might not even have a before. We are trying to count the socks of the universe, but the universe isn't wearing socks. It's weaving the fabric itself. So what is time? Time is the thing that stops everything from happening at once. Time is the heat death of the universe waiting to happen. Time is the curvature of space caused by matter. But most importantly, time is the mirror. It reflects the limitations of your own brain. When you look at a clock, you aren't seeing time. You are seeing a machine designed to comfort you. You are seeing a regulator for your society. Real time, physical time, is a wild, untamed beast that moves at different speeds, stops near black holes, and might not even flow at all. If this makes your head hurt, good. That means the translation scheme is breaking down. That means you are starting to see the cracks in the wall of common sense. Don't be afraid of the confusion. In science, confusion is not a dead end. It is the starting line. It means you are about to discard a comfortable lie for a difficult truth. Time is not what you think it is. It is so much more. And the fact that we, little biological machines made of stardust and anxiety, can figure this out, that is the greatest wonder of all.
The universe is not impressed by how confident you sound. It does not care about titles, degrees, or traditions. It only responds to one thing, whether you actually understand what's going on. Understanding the universe is not about collecting facts like trophies. It's about tearing ideas apart until nothing fake survives. Most people confuse knowing words with knowing things. They can name a phenomenon, define it, even teach it. Yet the moment you ask, why does it behave this way, silence appears. That silence is the border between memorization and understanding. To truly understand anything, you must be willing to look stupid first. You must ask questions that sound childish, simple, even embarrassing. Because nature does not reward sophistication, it rewards accuracy. If something is true, it will survive questioning. If it's false, it deserves to die. And here's the uncomfortable part. Authority means nothing to reality. An idea isn't correct because a famous person said it. It's correct because repeated experiments agree with it. When theory and experiment disagree, the theory loses every time. That's humility at the scale of the universe understanding. Also demands brutal honesty with yourself. If you cannot explain an idea in plain language, you do not own it. Complex jargon does not equal depth. It often hides confusion. Clarity is not simplicity for the weak. Clarity is simplicity earned through hard thinking. Another thing most people fear, uncertainty. They want final answers, permanent conclusions, mental comfort. But the universe doesn't work that way. Not knowing is not a failure. Pretending to know is. Progress comes from standing at the edge of ignorance and leaning forward, not from building fake certainty to feel safe. Curiosity is not passive interest. It is an aggressive desire to understand how things really work, even when the answer threatens your beliefs. And maybe the most important idea of all, understanding the universe should be joyful. Wonder is not separate from rigor. You can be precise without becoming dull. You can be serious without killing curiosity. The universe is not just a machine to analyze. It is a mystery that invites exploration, rewards honesty, and punishes intellectual laziness. If you want to understand it, don't worship ideas. Don't fear questions. Don't hide behind complexity. Ask, test, explain, repeat. That is how the universe reveals itself, not to the loudest voice, but to the most curious mind. Understanding beats memorization. Memorization is cheap. Anyone can memorize. A parrot can memorize. A hard drive can store more facts than any human who has ever lived. If memorization were intelligence, Google would be the smartest mind on earth. But it isn't, because knowing information is not the same as knowing reality. Understanding means something very different. Understanding means you can take an idea apart, turn it upside down, break, rebuild it, and still recognize it. It means the knowledge lives in your mind, not just on your tongue. When memorization fails, and it always does under pressure, understanding survives. Most education systems train people to repeat answers, not to ask questions. Students learn formulas without knowing where they came from. They learn laws without knowing why nature obeys them. They learn conclusions without ever touching the reasoning that produced them. This creates an illusion of knowledge, impressive on exams, useless in real thinking. The universe does not reward memorization. It rewards insight. You can memorize every equation about motion and still have no idea why something falls. You can recite definitions of energy and still not understand what energy is. When memorized knowledge meets a new problem, one not seen before, it collapses. Understanding adapts. Understanding transfers. Understanding creates. Real understanding begins the moment you say, "I don't get this yet." That sentence scares people because it exposes ignorance. But ignorance exposed is the first step toward truth. Ignorance hidden behind memorized words is permanent. If you truly understand something, you can explain it without hiding behind technical language. Jargon is not intelligence. It's often camouflage. Simplicity is not dumbing down. It is distillation. It takes far more mental effort to explain an idea clearly than to repeat it in complicated terms. Clarity is proof of ownership. Nature itself is brutally honest. It does not care how elegant your explanation sounds. It only responds to what actually works. You can memorize theories all day long, but one failed experiment is enough to expose the gap between knowing and understanding. Understanding also demands courage. It requires questioning what everyone else accepts. It requires the willingness to doubt books, teachers, traditions, not out of arrogance, but out of respect for truth. Progress has never come from obedient repetition. It has always come from someone asking an uncomfortable why. Memorization creates followers. Understanding creates thinkers. A memorized mind looks for instructions. An understanding mind looks for patterns. When something unexpected happens, the memorized mind panics. The understanding mind becomes curious. Curiosity is not a personality trait. It is a habit built by refusing to accept shallow answers. There is also joy in understanding, a deep, quiet satisfaction that memorization can never give. Memorization is mechanical. Understanding feels like suddenly seeing the picture after staring at scattered pieces. It is the moment confusion turns into clarity. That moment is addictive, and it is the engine of all discovery, but understanding is uncomfortable because it exposes how little you truly know. The deeper you go, the larger ignorance becomes. This frightens people who want certainty, final answers, and intellectual safety. But certainty is not a requirement for intelligence. Honesty is. To understand the universe, you must accept uncertainty as permanent. The goal is not to eliminate mystery, but to reduce confusion. Every answer opens better questions. That is not a flaw. That is how knowledge grows. Memorization asks, what should I remember? Understanding asks, why must it be this way and not another? That single shift changes everything. When you understand, you are no longer dependent on authority. You don't need someone to tell you what to think. You can test ideas against reality yourself. This is intellectual independence, and it is rare because it is demanding. Understanding takes time. It takes effort. It takes failure. You will be wrong many times. But being wrong while thinking is infinitely better than being correct by repetition. One builds insight. The other builds fragility. In the end, the universe is not a textbook to be memorized. It is a system to be explored. It speaks in patterns, not definitions. It rewards those who listen carefully, question deeply, and refuse to settle for surface-level explanations. Understanding beats memorization because memorization ends where learning should begin. And anyone serious about truth knows this. Facts fade. Definitions change, but understanding, once earned, becomes a tool you can use forever. Question everything, especially the obvious. The most dangerous ideas are not the ones that sound strange. They are the ones that sound so familiar that no one thinks to challenge them. The obvious is comfortable. It feels safe. It feels settled. And that is exactly why it deserves suspicion. Progress does not begin by attacking the unknown. It begins by re-examining what everyone assumes is already understood. Most people live inside borrowed conclusions. They inherit explanations the way they inherit language, without remembering when or why they accepted them. Once an idea becomes common, it stops being questioned. Once it stops being questioned, it stops being examined. And the moment examination ends, thinking ends. The universe does not label anything as obvious. That label exists only in the human mind. Nature simply behaves the way it does. When something feels obvious, it usually means we have grown accustomed to it, not that we have understood it. Familiarity is not evidence of truth. Repetition is not proof. Questioning the obvious is uncomfortable because it threatens stability. It forces you to admit that what you know might be incomplete or worse, wrong. That discomfort is not a weakness. It is the price of intellectual honesty. Every meaningful discovery has required someone to tolerate that discomfort longer than others were willing to. The obvious often survives not because it is correct, but because it is convenient. It fits into existing beliefs. It reduces mental effort. It avoids conflict. But convenience has no relationship with reality. The universe does not simplify itself to protect our comfort. When you stop questioning the obvious, you stop learning. You begin defending ideas instead of testing them. You confuse familiarity with understanding. At that point, knowledge becomes fragile. It works only as long as nothing unexpected happens. True questioning is not rebellion for its own sake. It is not cynicism. It is not disrespect. It is curiosity paired with discipline. To question something properly, you must be willing to follow the answer wherever it leads, even if it contradicts your expectations. The obvious collapses quickly under honest questioning. Ask where an idea came from. Ask what assumptions it depends on. Ask what evidence supports it, and what evidence could destroy it. If an idea cannot survive those questions, it does not deserve your confidence. Children ask powerful questions because they have not yet learned what they are not supposed to question. Over time, that instinct is trained out of them. Society rewards obedience more than curiosity. Exams reward correct answers, not good questions. Slowly, questioning becomes a risk instead of a habit. But the universe does not care what you were taught not to question. It only cares about what is true. Many of history's biggest mistakes were built on obvious ideas. Ideas so accepted that no one thought to test them. Once questioned, they collapsed quickly, revealing not stupidity, but complacency. Intelligence is not the absence of error. It is the refusal to protect error from examination. Questioning the obvious also reveals hidden complexity. What appears simple is often layered with assumptions. When you peel those layers back, you discover mechanisms, constraints, and patterns that were invisible before. That is where understanding deepens. There is also humility in questioning. It reminds you that your perspective is limited, that your experience is not universal, that certainty should always be provisional. This humility is not passive. It sharpens perception. It keeps the mind flexible. Some people fear that constant questioning leads to chaos. It does not. Blind acceptance leads to chaos. Questioning is what builds reliable knowledge. Structures that cannot survive questioning were never stable to begin with. When you question the obvious, you regain ownership of your thinking. You stop outsourcing judgment to authority. You stop mistaking consensus for truth. You begin interacting directly with reality, not second-hand interpretations of it. This does not mean rejecting everything. It means earning belief instead of inheriting it. It means holding ideas tentatively, ready to adjust them when evidence demands it. Strength of mind is not stubbornness. It is adaptability. The obvious is seductive because it feels complete, but completeness is an illusion. The universe is deeper than first impressions. Every surface explanation hides better questions underneath. Questioning everything does not make life harder. It makes it clearer. Confusion decreases as assumptions are exposed. Thinking becomes cleaner, sharper, more precise. In the end, questioning the obvious is not about being different. It is about being accurate. Reality does not reward agreement. It rewards those who ask the right questions and refuse to stop at comfortable answers. The obvious is where most people stop. That is exactly why it is where serious thinking begins. Nature doesn't care about your opinions. It never has, and it never will. The universe does not listen to arguments, intentions, or confidence. It does not adjust itself to fit beliefs, traditions, or personal preferences. It operates by rules that exist independently of what anyone thinks about them. You may dislike those rules, misunderstand them, or deny them entirely, and nothing will change. Opinion is cheap because it costs nothing to hold. Reality is expensive because it demands evidence. You can argue endlessly about how something should work, but nature responds only to how it does work. When belief and reality collide, reality wins without explanation or apology. This is why experiments matter. Not because scientists enjoy complexity, but because nature refuses to answer to words. It answers only to tests. A theory is not validated by how logical it sounds or how many people agree with it. It is validated by whether nature behaves the way the theory predicts. One failed prediction is enough to expose an error, no matter how elegant the idea. Human history is full of confident opinions that reality crushed. People once believed heavier objects fell faster than lighter ones. It felt obvious. It matched intuition. Nature disagreed. No amount of arguing could convince gravity to cooperate with opinion. Only observation forced correction. Nature is brutally fair. It treats all ideas equally by testing them. It shows no favoritism to authority, tradition, or popularity. An unknown thinker with a correct model will always outperform a famous thinker with a wrong one. Truth is not a vote. This indifference is not cruelty, it is clarity. Because nature does not care, it provides a reliable standard. Personal bias cannot bend it. Emotional attachment cannot soften it. This makes nature the ultimate referee in every intellectual dispute. The danger begins when people confuse explanation with control. Naming something does not grant power over it. Describing a law does not make it optional. Understanding is not command, it is alignment. You do not tell the universe what to do. You learn what it does and work with it. Opinions feel powerful because they are internal. They create certainty without effort. But that certainty is fragile. The moment it is tested against reality, it either adapts or shatters. Refusing to test opinions does not protect them. It merely delays failure. Reality has no obligation to be intuitive. Many truths feel wrong at first. They contradict common sense. They challenge everyday experience. This is not because nature is strange. It is because human intuition evolved for survival, not accuracy. When intuition conflicts with evidence, intuition must yield. Nature also does not explain itself. It does not offer comfort or meaning. It simply behaves. Any understanding we gain is earned through careful observation, measurement, and repeated testing. This makes knowledge slow, difficult, and incredibly valuable. Respecting nature's indifference is a form of intellectual maturity. It forces humility. It reminds you that being convinced is not the same as being correct. It teaches restraint, to wait for evidence before forming conclusions, and to remain willing to abandon them when evidence changes. This attitude extends beyond science. In any system governed by reality, economics, engineering, health, technology, opinions detached from evidence fail. Bridges collapse, markets crash, bodies break. Reality enforces its rules without debate. Nature does not punish ignorance out of malice. It simply reveals it. Failure is not personal. It is informational. It shows where understanding ends and assumption begins. Those who learn from this adjust. Those who argue with reality repeat the same mistakes. There is freedom in accepting that nature does not care. It removes the burden of defending beliefs. It shifts focus from being right to finding out. It replaces ego with curiosity. Instead of asking, "Do I believe this?" you ask, "Does it work?" Progress depends on this mindset. Every advance comes from submitting ideas to reality and accepting the outcome even when it disappoints. This is not submission in a weak sense. It is alignment with the only judge that cannot be fooled. In the end, opinions are stories we tell ourselves. Nature is the story that continues whether we listen or not. Understanding grows when we stop trying to persuade the universe and start paying attention to it. Nature doesn't care about your opinions, and that is precisely why it can teach you the truth. If you can't explain it simply, you don't understand it. That statement sounds harsh, but it is precise. Complexity often feels impressive, yet it is usually the refuge of confusion. When an idea is truly understood, it becomes flexible. It can be reshaped, translated, and expressed in different forms without losing its meaning. When it is not understood, it becomes rigid, dependent on exact wording, formulas, or jargon to survive. Many people mistake difficult language for deep thinking. They hide behind technical terms, not because the idea requires them, but because they themselves are unsure what the idea actually means. Complicated explanations can create the illusion of intelligence, but illusion collapses the moment clarity is demanded. Simplicity is not the absence of depth, it is the result of depth. To explain something simply, you must see its structure clearly. You must know what is essential and what is decoration. You must understand cause and effect, not just labels and outcomes. This takes work. It takes struggling with the idea until it becomes transparent. A memorized explanation cannot be simplified. It breaks if you try. An understood idea can be rebuilt from scratch. You can start from first principles, use analogies, draw examples, and still arrive at the same conclusion. That is how you know the idea is yours. The test of understanding is transfer. Can you apply the idea in a new situation? Can you teach it to someone without assuming prior knowledge? Can you answer unexpected questions without panicking? If the answer is no, then the knowledge is incomplete. Simplicity also exposes flaws. When you try to explain something clearly, gaps appear. Assumptions become visible. Weak reasoning reveals itself. This is uncomfortable, which is why many avoid simplifying. It forces confrontation with what you do not yet understand. The universe itself is not complicated in expression. It is precise in behavior. The laws that govern it are simple in form, even if their consequences are rich and complex. Complexity emerges from simple rules interacting, not from vague or mystical explanations. Clear explanations respect the listener. They assume intelligence, not prior expertise. They invite engagement rather than intimidation. Confusion does not make an idea more true, it only makes it less accessible. There is also honesty in simplicity. It prevents exaggeration. It prevents hiding uncertainty behind fancy words. When something is not fully understood, simplicity forces you to say, "This part is still unclear." That admission is not weakness, it is accuracy. Education fails when it rewards repetition instead of explanation. Students learn to recite without understanding. They pass exams yet cannot explain what they have learned in their own words. This creates fragile knowledge that disappears under pressure. True understanding creates confidence, not arrogance. You do not need to dominate a conversation or impress an audience. You can explain calmly, clearly, and adapt to the listener. You are not protecting the idea, you are sharing it. Simplicity is also a tool for discovery. When you try to simplify an idea, you often discover better questions. You strip away unnecessary detail and see the core problem more clearly. This leads to deeper insight. The fear of oversimplification is often exaggerated. Oversimplification removes truth. True simplicity preserves it. The difference lies in understanding. Without understanding, simplification distorts. With understanding, it clarifies. In any field, the best thinkers are the clearest communicators, not because they aim to be popular, but because clarity is the natural byproduct of deep comprehension. They know what matters and what does not. If you want to know whether you truly understand something, try to explain to a curious child or to yourself without notes. If you stumble, if you rely on memorized phrases, if the explanation collapses, the work is not finished. Understanding is not proven by how much you can say. It is proven by how little you need to say without losing meaning. If you can't explain it simply, you don't understand it. Not yet. And that yet is an invitation to think harder, dig deeper, and earn clarity instead of performing intelligence. Uncertainty is not weakness, it's intellectual honesty. The desire for certainty is one of the strongest human instincts. We want clear answers, fixed conclusions, and solid ground beneath our thinking. Certainty feels safe, it feels like control. But the universe does not offer that kind of comfort. It offers evidence, probabilities, patterns, and a constant reminder that our understanding is always incomplete. Pretending to be certain does not make you intelligent, it makes you rigid. Intellectual weakness is not saying, "I don't know." Intellectual weakness is being afraid to say it. The moment you claim absolute certainty, you stop listening. You stop testing, you stop learning, you replace curiosity with defense, and defense has never discovered anything new. Honest thinking begins where confidence ends. It begins with the recognition that every explanation is provisional, useful, but not sacred. Reality does not reveal itself all at once. It reveals itself slowly, through error, correction, and refinement. Certainty blocks that process. Uncertainty keeps it alive. Many people treat doubt as a flaw, as something to be eliminated. In truth, doubt is a tool. It keeps ideas flexible. It forces them to face evidence repeatedly. Without doubt, beliefs harden into dogma, and dogma resists reality instead of learning from it. The universe is not built on final answers. It is built on patterns that work until they don't. Every law, every model, every explanation has limits. Acknowledging those limits is not surrender, it is accuracy. Ignoring them is arrogance. Uncertainty also separates belief from evidence. Belief demands commitment. Evidence demands attention. When you admit uncertainty, you shift from defending ideas to investigating them. That shift is the foundation of progress. There is a difference between being confused and being uncertain. Confusion is lack of understanding. Uncertainty is understanding the boundaries of your knowledge. One is temporary ignorance. The other is intellectual maturity. History rewards those who were comfortable being uncertain. Every major advancement came from someone willing to admit that existing explanations were incomplete. They did not destroy certainty recklessly. They questioned it carefully. That care made discovery possible. People often mistake confidence for competence. A confident voice can sound convincing even when it is wrong. Nature is not impressed by confidence. It responds only to what is correct. Uncertainty, paired with testing, is far more reliable than confidence without evidence. Living with uncertainty requires courage. It means resisting the urge to close questions prematurely. It means tolerating ambiguity while continuing to think clearly. This is difficult, which is why certainty is so tempting. But temptation is not a guide to truth. Uncertainty also protects against self-deception. When you accept that you may be wrong, you are more likely to notice errors. You become alert instead of defensive. You trade pride for precision. Some fear that uncertainty leads to indecision. In reality, it leads to better decisions. Acting with awareness of uncertainty encourages caution, adaptation, and revision. Acting with false certainty encourages recklessness. Intellectual honesty demands that you distinguish between what you know, what you think you know, and what you do not know. Blurring those categories creates confusion. Respecting them creates clarity. The strongest thinkers are not those with the loudest conclusions, but those with the sharpest questions. They move forward without pretending the road is finished. They revise without shame. They abandon ideas without regret when evidence demands it. Uncertainty does not paralyze progress. It guides it. It tells you where to look next. It tells you which assumptions need testing. It keeps thought dynamic. To understand the universe is not to eliminate mystery, but to engage with it honestly. Every answer opens deeper questions. That is not failure. That is success. Certainty ends conversation. Uncertainty begins discovery. Uncertainty is not weakness. It is respect for reality. It is the discipline of admitting what the evidence allows and nothing more.